Hello, this is a video explaining how to do lesson 7 of unit 3, which is quadratic word problems. You have, I believe, seen these questions prior to this in physics if you're taking physics, but we are doing the easier route than they are. So you are given the equation on each one of these. You don't have to do any calculations, you'll just be looking in the calculator. And I'm going to have you just draw or practice drawing a diagram for each question because I think that will help us in the long run as well as in your physics class. So up here at the top it says, now that we have covered how to solve quadratic equations as well as how to graph them, we're going to look at how these equations can be used in real life. These word problems are often seen in your other non-math courses such as physics or chemistry. And I believe you guys used this one with physics, like making this equation. Like I mentioned, I'm going to give you this equation each time for these problems here. So how to solve word problems. Step 1, read the question, draw a diagram. Step 2, identify all values needed for the equation. Step 3, label and list the values given in the problem and identify the unknown. And step 4, solve the unknown using algebra and your calculator. These steps also fit for if we didn't have the equation. So if you do have any of these questions later on in physics or chemistry or anything like that, you would be able to use these steps to apply to that as well. Looking at example number 1, it says Mia launches a toy rocket from a platform. The height of the rocket in feet is given by the equation h equals, where t represents the time in seconds after launch. Interpret the coordinates of the vertex in context, aka use the graph to find the vertex and explain what that means in words. So I'm going to go ahead and draw a diagram first. We have a toy rocket coming off a platform. A platform would just be something that someone's standing on. So here's my platform. And here's my little rocket. I'm going to be clear, I'm not claiming for this to be a good rocket. There we go. And then she's going to launch it off the platform. It's going to go up into the air. And then eventually it'll come back down into the ground. Here is the ground. And this is the rocket. Here we go, on the ground. Perfect. Now what we're going to do is make this look more like a graph. Here would be the x-axis, and this one here would be the y-axis, kind of along where that rocket is thrown off. It is very important that you properly label your axes. That is how you will know what you're looking for and how to find what you're trying to find. So here it says the height of the rocket in feet, where t represents the time in seconds. You'll notice t is replacing x for us here. So this is the x-axis. That means this one is time in seconds. And that means that our y would have to be feet. You can say height in feet. Now we're looking for a vertex. Remember, the vertex is the very center point. The problem is we don't have the rest of the other side, right? If this was a whole parabola, it would go through 0 because 0 is not here at 0, it's up here. And it would start over here, so it'd be the middle of these two things. So the easiest way to find the vertex is to identify the max point or the maximum point, because that is also the vertex. They're in the same place. So it'd be somewhere right in the center-ish, right? It's a little bit over to one side, but this is the highest point here. And this would be the vertex. Other important points that I'm always going to label. I'm always going to label the vertex, like we just said. I'm always going to label the y-intercept, because that's going to be the starting point. And then I'm always going to label the root or the 0. And that's when the object hits the ground again. That would be right here, because that tells me how long it took for whatever my projectile is to be in the air and then to come back down and hit the ground. Because this point here is judging how long in seconds from the start over to where it hit the ground. And the way I'm going to find this is to graph it in my calculator. So I'm going to go ahead and split screen you and put you on Desmos. Obviously you can use TI for this as well if you're doing this in class. Okay, here is our diagram next to our graph. and I'm going to find these points we're talking about, the vertex, the y-intercept, and the 0. The y-intercept should be easy to find. It's going to be just on the y-axis, wherever our x value is equal to 0. And you can see that right there, 0, 40. 0, 40. Then we're going to look for our vertex. That's going to be the very center here, the highest point. That is 0 0.75, 49. And then our 0, or our root, is going to be where it touches the x-axis. Obviously, I'm not going to pick this one, -1, because time can't be negative. So I'm going to pick this one. It says 2.5, 0. And let me move that out of the way. And here we go. So I'm going to label them on my diagram as well. Start over here. Here is our y-intercept. That one's at 0, 40. So what this tells me, as I'm sure you've already figured out, is that I am 40 feet off the ground when we let go of the rocket, because that is the y-axis point right here. Next one I'm going to label is the vertex. This one's at 0 0.75, 49. Remember, x or t is seconds, and y is feet, or h. Y or h is feet. So this says at 0.75 seconds, the rocket is 49 feet high. And it doesn't go any higher than that because this is the highest point. And then this one over here, this one is when I hit the ground. And that point there is 2.5, 0, telling me, remember, x is time and y is height. So 0 would be on the ground because I have a height of 0 feet. And it took 2.5 seconds to get there. So this rocket was in the air for 2.5 seconds before it hit the ground. Now I'm going to answer my exact question. It says, interpret the coordinates of the vertex in context. Here's our vertex. This vertex says that our rocket is at 49 feet, a max height of 49 feet after 0.75 seconds. At a max height of 49 feet after 0.75 seconds. And that would be the answer. Let's look at number 2, and then you can try some on the next page. Number 2 says, Annabelle kicks a football. Its height in feet is given by the equation, where t represents the time in seconds after the kick. What is the football's greatest height? This one does not specify that we're kicking off of a platform, so we are going to assume we're kicking off the ground. So I'm going to draw them a little. Here's the football. Not claiming it's a good football. Here's the ground. And the football's going to go in the air, and then eventually it's going to hit back on the ground again. Here is the y-axis there. This is y, this is x. And remember, the most important part here is labeling. So height in feet. Okay, and then it says t represents time in seconds. That means here, where I'm at the ground, this would be 0, 0. You can see it's at the origin. So I'm starting at 0 seconds in 0 feet, and then we're flying up to a height of something right here. And then after this many seconds, we don't know how many, it hits the ground again. What is the football's greatest height? So this one is asking us, how high does the football go? High would be feet, so we're looking for the y value of our vertex right here. So it's looking for max height, question mark. Now I'm going to write down the 3 points I'm always going to get from my graph. I'm always going to get my vertex, which is the center point there, which is going to give us the answer. I'm always going to get my y-intercept, that tells me where I'm starting. Then I'm always going to get my 0 or my root, because that tells us how long it took to hit the ground again. Okay, I'm going to go ahead and split screen and graph this, and then I'll be right back. Here is our graph. I'm going to zoom in a little bit here and show you. Here is our y-intercept here at 0, 0, which we already assumed because we were starting at the ground. Here is the other root, and this is how long it took us to hit the ground again. So it's 6, 0, meaning it took 6 seconds for the football to hit the ground. I'm going to come up here for my vertex. Here's that point right there. 3, 144. And that would be, remember, 3 is the x value, y is the 144. And this says it took 3 seconds for the football to be at 144 feet in the air. And that was our highest point there. So I'm going to label them on my graph. This was 0, 0. This one was 6, 0, so 6 seconds till it hit the ground again. And then this one here was 3, 144, which means it took 3 seconds to get to a height of 144 feet. And then what is the football's greatest height? The answer there is 144 feet. Don't forget to use your units as long as they're given to you. Okay, I'm going to go ahead and we're going to work on number 3. And this one down here, number 6, these are both over how high does the ball go. So go ahead and pause, see if you can do number 3 and number 6, and then come back to check them. Welcome back. Here is example number 3. I have drawn the picture, our rocket. It says just was launched in the air. If it does not specify a platform, you can assume it's launched from the ground. And then I labeled over here my feet and my seconds. Like I mentioned before, it's super important that we practice labeling our axes, because when you're trying to write the answer on your own, you can get really lost in the numbers if you don't know which number means what. And then we're given our equation here, and it says, what is the rocket's greatest height? So I drew my diagram, I graphed it in my calculator, and I found that the y-intercept was 0, 0, that the root was 9, 0, and the vertex was 4.5, 324. What I can take away from that, we started here at the origin 0, 0. This is 0 seconds and 0 feet off the ground, so it's all on the ground. And then it rose up to a height, here a maximum height of 324 feet after 4.5 seconds. And then it hit the ground again here at 9 seconds, because it says 9 seconds and 0 feet in the air because it's on the ground. That means if you were asked like how long was this rocket in the air, you would say 9 seconds. And then our answer, what is the greatest height, was 324 feet. Our last one down here at the bottom, number 6, basically the same question, but this time it was a ball and the ball was kicked off of a platform. But it still asks what is the greatest height that the ball achieves. So I drew a picture here including the platform. Remember, the platform just means we don't start at the origin. It just means that if we were to like draw the actual graph without parameters, it would end like somewhere over here. So this is not a very good graph. Here I labeled my seconds and my feet. It's not always going to be feet. Sometimes it'll be meters or miles or whatever. And then I wrote down my points from the graph. Here's what I found in my calculator. The y-intercept is 0, 18. That is right here, which means that my ball was on a platform that had a height of 18 feet. Next, I have a vertex of 0.75, 27. That means we hit our max height of 27 feet after 0.75 seconds, so pretty quick rocket there. And then our 0 here is when it hits the ground again, and it hits the ground again after 2.05 seconds. I just rounded that one. So the answer was our max height of 27 feet, and it was multiple choice. I picked that one. It is C. And this question I did take directly off some SAT practice. We do take our SAT soon, so I hope this will be helpful. Looking here at number 4 and number 5, number 4 is asking, according to the model, at what speed in miles per hour does the car obtain its greatest mileage? And then number 5 says, given the equation, height is in meters and t is in seconds, a ball kicked off the ground. After approximately how many seconds will the ball hit the ground? This one isn't asking for height. It's asking for what period of time until the ball hits the ground again, meaning how long is the ball in the air, which we've talked about multiple times. It's going to be this number here when it hits the ground again. And then this number 4 is a weird one. So let's do number 4 together, then you can try number 5. Number 4 here is going to be really important that you draw your diagram correctly. So I'm going to draw my axes here. This is not my y. This is my x. This is y. And it says the gas mileage m of s in miles per gallon of a car traveling s miles per hour is modeled by the function m of s equals. You can see here s is taking the place of x. So we would assume that miles per hour s is the one that's going to be on the x-axis. So I'm just going to label that miles per hour. And that means that the other direction, so the y would be this gas mileage or miles per gallon. And then you can see we do have a cutoff here. It only wants us to look when it's between 20 and 75. So what I'm going to do is just mark 20 and 75. Is I don't know what's happening at those times, but I also want to make sure I'm still properly drawing my diagram. And what I'm going to do is actually graph this now, which I know it feels a little early. I haven't drawn my line yet, just to see what it looks like. Okay, here is my graph. I did go ahead and trace just to have it graphed correctly. So I traced along with my finger here to get approximately 20 and approximately 75 over on this side. And that got me to 20 was at 13 miles per gallon, not even close to feet. And then 75 was at 15 miles per gallon. This is what we're looking like. And then it wants to know the greatest gas mileage. So I'm going to look back at my diagram. This is why diagrams are so important. We can see here, gas mileage or miles per gallon is on the y-axis. So it wants to know when is it highest on the y-axis, which is just like what we've been doing. It's just asking for basically the same as the height. It's just asking for the highest point on the y. So I'm just going to click over here for my vertex. And that one is at 48, 46. There we go. And what I'm going to do here is just make sure I know what it's asking for. It says, according to the model, at what speed in miles per hour does the car obtain its greatest gas mileage? So remember, this one is the y value. That is miles per gallon. And then this one here, my x value, is miles per hour, which would be called speed. What am I drawing with this sheep here? Speed, sorry. So our speed there is 48. So I'm going to pick that one. That is B. Notice how easy it could have been to get this one wrong if you weren't super careful with reading the question. That is why they do them like this. This is something to be expected, to be able to narrow it down to 2. So you'd really have to know what you're talking about. And our last one here, number 5, I would encourage you to try to pause, see if you can do this one on your own, and then come back and we'll check it. Welcome back. Here is number 5. So go ahead and check that you did your diagram correctly. This time we were in meters, not feet. And our seconds was still along the x-axis. And it told us the ball was kicked off the ground. So I kept that ground right there. And it asked, after approximately how many seconds will the ball hit the ground? So it's asking not how high it goes or when it's at its highest point. It's asking how many seconds does it take to get to here. Remember, seconds is our x value, and that's given right here. So it would take us 5.1 seconds to get to the ground again. And the one that would round properly to that would be D, which is 5.0. Hope this was helpful, and good luck.